Hi guys, welcome back to Econ Time with SK. So grab your notebooks, your favorite cup of coffee, and let's get started. So let me first summarize what we're going to cover in this lecture. First, we are going to look at the relationship between marginal product and marginal cost. Okay? So really what we are interested in is what determines the shape of the marginal cost curve, okay? And also sort of understand why are the MP and MC curve mirror images of each other. So these are what the two things that we want to focus on when we're looking at relationship between marginal product and marginal cost curves. So moving on to our first slide, the marginal product curve is the mirror image of the marginal cost curve that is shown below. And notice that, all right, this is something you guys need to be aware of. Look at the fact that the x-axis here includes labor or variable input, whereas the x-axis for the marginal cost curve is actually quantity. It's the total output that's being produced by the firm, right? And just for ease of reference, I'm going to call this A dash, which corresponds to the minimum point of, right, the minimum point right here in the marginal cost curve. So the key question, as I said, we're asking is why is the marginal cost curve a mirror image of the marginal product curve? So what is the relationship between MC and MP? So let me just write down first what is the formula for the marginal cost curve. Marginal cost, by definition, is the change in total cost due to change in quantity. All right, so this is the definition of marginal cost. Essentially, we're looking at as we increase output by 1 unit or by an additional unit, how does total cost change? For our own convenience, let me just draw the marginal product curve right here. So this is the marginal product curve, right? It looks like this, and this, as we said, is, let's call it A dash. So what we're seeing is before A dash, there is increasing returns, right? Okay. And by increasing returns, what we mean is that as you're adding more variable inputs, let's say labor, as you're hiring more labor, the contribution to total product actually is more and more every single labor added, right? So remember, we said that, hey, guess what? The total product actually increases at an increasing rate. Let me just write that down. So before A dash, we've got increasing returns or increasing marginal product, which means that as we, let's say, hire more labor and raw material, yes, the cost of production goes up. So the total cost goes up. But at the same time, because there's increasing returns, more and more is being added by each labor hired. That is why the change in quantity that's happening, it's actually much higher than whatever is the change in total cost. So if I were to put this into the formula for marginal cost, what we're saying is that this increase in Q is a lot more than the increase in total cost. So if the denominator, if what is at the bottom is rising a lot more than what is at the top, the numerator, then essentially what is happening? What we're going to see is that the marginal cost actually decreases. Now, if I were to draw the MC curve right here, right below the marginal product curve, so what we've got is, let me just trace down. All right. So from the marginal product curve, I'm just drawing a vertical line down so that I can actually have a point, corresponding point A. And what we're seeing is, hey, you know what? When there's increasing returns, as we found out that when there's increasing returns, marginal cost actually goes down. So I'm going to just draw that. So this is the portion where the marginal cost is going down. Let's now do the other part. All right. So let's do what happens after A dash. So after A dash, right here, what do we see? We are seeing that there's decreasing returns. So marginal product is falling. Okay, so let me actually write that down. Okay, after A dash, marginal product is decreasing, which means that yes, you're going to still hire more labor and raw material, right? So there is this increase in the cost of production, that is, total cost does increase. But what we're saying is that, hey, you know what? Now, because of this diminishing returns, the increase in total cost is going to be much more than the increase in output. There's diminishing returns, so the increase in quantity isn't going to be that much, and so the rise in total cost actually ends up being more than the rise in quantity. So if I were to write this down, marginal cost formula is change in TC by change in Q. Well, now we're saying, hey, guess what? The total cost actually increases much more, but the quantity doesn't increase by so much. So now they're still hiring more labor and raw material. The total cost is increasing, but because of diminishing returns, the increase in quantity is actually much less now than the total cost increase. And so what we're seeing is that marginal cost actually is going to start rising. So when MP is decreasing, marginal cost is rising, which means if I were to draw this now, this portion would be something like this, right? So now you can see this mirror image of each other, this inverse relationship between the marginal product curve and the marginal cost curve. So what if I ask you, why is the marginal cost curve first decreasing and then increasing, right? So what I'm asking you is, hey, why does the marginal cost curve look like this? And what is the answer that you're going to have here? The key reason is basically because of law of diminishing returns. Okay, so don't say, oh, it's because the MP is falling and then it's rising, or don't say anything about like mirror images and stuff. Essentially, it is the law of diminishing return that determines the shape of the marginal cost curve. All right, so let's see. If I were to just break it up right here, what I'm saying is, hey, you know what? This shows diminishing returns, and this part is actually falling because of increasing returns. All right, guys, I shall see you in the next video. Take care. Bye.